Algebra 2 students, this is lesson 5.2, which is solving quadratics by graphing. So quadratic equations are quadratic functions set equal to a value. And we want, for the matter of solving them, we want that value to be equal to 0. So we want to be making sure that we are getting them equal to 0 and then solving. Now, in solving something like ax squared plus bx plus c equals 0, the solutions are called the roots of the equation. And one method for finding the roots is to find the zeros, which are the x-intercepts, where the graph crosses the x-axis, where the parabola crosses the x-axis, by graphing. So a couple examples. X squared plus 2x minus 15 equals 0. So if I was going to solve this by graphing, the vertex would be negative b over 2a, which would be negative 1. If I plug negative 1 back in for x, so I'd have negative 1 squared, which is a positive 1, plus 2 times negative 1 minus the 15. So putting this together, I would have a y coordinate of my vertex to be a negative 16. So graphing this, you can see my vertex would be way down here. Now we could make a table of values and so on, but we could also realize that since the a value is 1, that I'm going to go over 1 and up 1, which would put me right here using symmetry, and then I'm going to go over 1 up 3, which would put me right here. Again, I'm using symmetry, and then over 1 up 5. Which puts me about right here. And then the next one will be over 1 up 7. And if you count this, that's going to put us right on the x-axis. And you could do this using a table of values also. So this parabola looks like this. It's a very rough shape of that. And your zeros, which are your roots, would be negative 5 and positive 3. X would be negative 5 and positive 3. Now we'll talk about this a little bit in the next lesson, but if negative 5 is a root, that means x plus 5 would be a factor, and if positive 3 is a root, then x minus 3 would be a factor. And then we're going to talk about the FOIL method. So if we FOIL this, taking our first terms, x times x is x squared, this would be minus 3x would be our outside terms, positive 5x would be our inside, and negative 15 would be our last terms. And then if we combine like terms, you can see we get that original equation. But that's all coming next. This next particular equation, first of all, we got to get this to equal 0. So I'm going to add 12 to both sides. If I find my vertex, which would be negative b over 2a, which I have an x coordinate of 4. If I plug 4 in there, I'd have 16 minus 32 plus 12, which I believe comes out to be a negative 4. So my vertex would be 4, negative 4. All right, my A value is 1 here, so I know I'm going to go over 1 up 1. Which will give me those 2 points. And my next one will be over 1 up 3, which puts me right there and right there. So these cross the x-axis exactly at the point negative 2, or positive 2, sorry, and positive 6. So those would be my 2 solutions here. Now, obviously, some cases they may not cross the x-axis at exact values. So for example, in this one, this is number 2 on the 5.2 study guide, my vertex would be negative 6 over 2, which would be negative 3. If I plug negative 3 in here, I'd have 9 minus 18 is a negative 9 plus 6, which would be a negative 3. And now if I graph this, I have negative 3, negative 3. My A value is 1, so I'm going to go over 1 up 1. Which puts me right there. And then when I go over 1 up 3, you can see I cross the x-axis. And so when I graph this, it's crossing the x-axis, but not at an integer value. We would say there it's going to cross it between negative 5 and negative 4, and it would cross between negative 2 and negative 1. And that would be all we're concerned about, is between the 2 consecutive integers, where is it crossing, where would the solutions be? And this is a good example of a problem why graphing is not always the best method. Looking at this next one, number 5 on that same study guide, the vertex would be negative b over 2a, so that would be 3. Plugging 3 in, we're going to have 3 squares 9, or 18, minus 36, plus 17, which comes out to be a negative 1. So now I know my vertex is 3, negative 1. And my next movement is to go over 1. Since my A value is 2, I'm going to go over 1 up 2, then over 1 up 6. It's the A, 3A, 5A. But if I go over 1 up 2, I'm already crossing the x-axis. My parabola is going to look like this. And so you can see your zeros are between 2 and 3, and between 3 and 4. So this is solving quadratics by graphing. Remembering this is not always the best method, especially when they are not going to be integer values.